Okay guys, welcome back. So this is the next lecture in trigonometry, class 11 mathematics. In the previous videos for trigonometry, we have covered the basics of trigonometry, like what are angles, what are the different conversion types, some what are the signs, domain, ranges, graphs, and even saw some functions of sum and differences of angles. Right now, there's the next part to it. Like this time, what we are going to do is we are going to cover the sum and differences of angles of trigonometric functions, including tan and cot. Right. So the key thing that we have to look into this time is tan of x plus y. Right. Now, what is tan? We know. So tan of x plus y we have to find. So what we can do is we can take sine of x plus y upon cos of x plus y. Right. Now we have the expansion for sine of x plus y is sin x cos y plus cos x sin of y. Right. And here it is cos x cos y minus sin x sin y. Right. So that's the only option available to us. Write it as a ratio of sin and cos, expand sin and cos, because these are the formula that we are well aware of. Right. Now, what we can do is we can simply take the ratios. So let's take the ratios. So how it goes is so what we can do is divide by cos x cos y both the sides, right? So when we divide cos x cos y gets cancelled and we become tan x, right? And when we divide this by cos x cos y, the cos x cancels and it becomes tan y, right? So numerator becomes tan x plus tan y upon this gets cancelled 1 minus tan x tan y, right? And this is what we wanted, right? We wanted tan x plus y in terms of tan x and tan y. So this is what we are able to get, right? So definitely tan of x plus y, right? Okay, so this is formula. This is a good formula, right? Now, from here we can derive tan x minus y, definitely like we used to do for all other sums and differences. So now when we replace y with minus y, so in case of tan, minus y is like tan of minus y is minus tan of y, because cos remains the same and sin of y changes the sign, right? So it becomes tan x remains the tan x minus tan of y, and upon 1, since this is positive, this is negative, so 1 plus tan x tan y, right? So now this is the other formula, right? So there are two formulas for tan x plus y and tan x minus y, right? Now, likewise, we can derive the formula for cot x plus y and cot x minus y. So simply, what we have to do this time is take the reverse ratios, that is cos upon sine. So let's see. So when we look into cos of x plus y is cos of x plus y upon sine of x plus y, right? This is something that we can easily write. Now we have the expansion for this. So I know the expansion of numerator is cos x cos y minus sin x sin y upon sin x cos y plus cos x sin of y, right? Now here in this case, what we can do is let's divide again by cos x cos y, right? So when we divide by cos x cos y here, or rather let's divide by sin x sin y, because what we want is, since we are expanding for cot, we need cot here. So if we divide by cos, it's going to become a tan. Instead we want a cot, so let's divide by sin x sin y. So what becomes here is this becomes cos x cos y upon sin x sin y, that is cot x cot y, and this becomes minus 1 upon this becomes sin x cancels cos y by sin y, and you keep cot y plus cot x, right? So this is the formula for cot x plus y, and likewise we can get cot of x minus y simply is equal to, now what happens in this case, right? Let's see. So when we make it minus y, so it becomes this becomes negative, right? So let's make it negative. Cot x, cot y plus 1, right, upon 4 is minus, upon this will be cot x minus cot y. So let's make it cot x minus cot y, and since there is a negative sign here, so let's do, let's include this minus sign here and let's make this as cot y minus cot x, right? Cot y minus cot x, right? So this is the formula for cot x plus y and cot x minus y, right? So now what we can do here. So this is, since we know now, so till now we know the formula for all the functions like a plus b, a minus b, right? So since we know a plus b, and also what we can do is we can find the formula for two types of a function, right? So suppose we look for cos of 2x, right? So what it will become is cos of x plus x, right? So let's expand it, right? So it becomes cos a cos b, cos a cos b, cos x cos y minus sin x sin y, right? This is nothing but cos square x minus sin square x. That's one expansion of cos 2x. Now we know that sin square x plus cos square x is 1. So what we can do is we can replace sin square x by cos square x minus 1 minus cos square x. It becomes positive, so it becomes 2 cos square x minus 1. That's another expansion. So that is first expansion, that is second expansion. Now third one will be when I replace cos square x 1 minus sin square x, it will give me 1 minus sin square x minus sin square x, so that is 2, right? Those are the three expansions, right? Now this is very good, so if we, depending on the type of problems we are solving and what do we want as a result, we can expand it as difference of two squared, that is cos and sine, or just keep it as a function of cos or keep it as a function of sine, right? Now in addition to this, there is another fourth one which becomes let's take this one, right? So let's take this one. It becomes cos square x minus sine square x, right? Let's divide whole things by cos square x plus sine square x, right? We can do that because this thing is either case 1. We know that's an identity, right? Now what we can do is let's expand it in the terms of 10. So let's divide everything by sine square x or rather cos square x, right? So it becomes 1. And this becomes 10 minus 10 square x, right? And this becomes again 1, and this becomes 10 square x again, right? So this is the fourth expansion, right? So cos 2x is good for expansion, right? If we want cos 2x to turn in terms of 10, then we have this expansion, right? So these are good 4 expansions that we should remember, and then we can see some problems. We will see some problem that will take use of using this expansion, this expansion, and sometimes this expansion, right? So these are 4 that we should remember for cos 2x. These are very important. There are many questions which are framed on this side. Okay. Now, since we did for cos 2x, let's do for sin 2x. Right? Sin 2x is nothing but sine of x plus x. It gives sin x, sin a cos b plus cos a sin b, right? So this is nothing but both the terms are same. It becomes 2 times sin x cos x, right? So that is good expansion of sin 2x, right? Okay, so that's good. Again, what we can do is we can now divide it by 2. Let's write it 2 sin x cos x upon sin square x plus cos square x. We can divide again by this function because this is again 1. Now what we can do is let's divide it entire thing by cos square x. So it will give 2. 1 cos will get cancelled and this becomes 10x. 2 10x upon this becomes 1. This part becomes 1 and this becomes 10 square x, right? Right? This becomes 10 square x. So again this has 2 expansions, sin 2x. One in terms of sin and cos, other in terms of tan x, right? So 2 tan x upon 1 plus tan square x, right? So sin x has 2 good expansion, and we should remember this is used number of times when we are moving from sin into sin and cos domain, and this is used when we are moving to tan x domain, right? Can we do similar things for tan 2x? Let's see. So what we can do for tan 2x is nothing but tan x plus x, right? So what we remembered for tan a plus tan b, tan a plus tan b upon 1 minus tan a tan b, that is tan x plus tan x upon 1 minus tan x is this becomes 2 times it essentially becomes 2 times 2 tan x, right? So 2 tan x upon 1 minus tan square x is the expansion for tan 2x, right? Now since we have tan 2x, can we do for 3 times of an angle, right? So can we do for 3 times of an angle? So let's do for sin 3x. Let's plan to do for sin 3x. So suppose we have sine of 3x. This is nothing but sine of 2x plus x, right? So now it will require the expansion of 2x, right? So what is sin 2x plus x is sin a plus b is sin x, sin a cos b plus cos a sin b, right? So this is the expansion. Okay. Now we are looking for sine, so we need everything in terms of sine. So let's see, can we do something, right? So when we convert this sine into cos, it becomes 2 sin x, and cos x becomes cos square x, right? So we are expanding it as 2 sin x cos x, right? Sin 2x. And cos 2x we have to expand in terms of sine. So it becomes 1 minus 2 sin square x into sin x, right? So I expanded this cos 2x in terms of 1 minus 2 sin square x, so I want everything in terms of sine. Now we can find one cos, but we know this cos is nothing but 1 minus sin square x. So it becomes 2 sin x into 1 minus sin square x. Let's expand this, plus this becomes sin x, and this becomes 2 sin cube x, right? Let's expand this, it becomes 2 sin x minus 2 sin cube x, right? And this again comes in sin x minus 2 sin cube x, right? Now it becomes 4 sin cube x, 3. So it becomes 3 sin x minus 4 sin cube x, right? So that is sin 3x. That's a good expansion again, but no need to remember it. If you want, well and good. Otherwise, it takes like another 30 seconds. But yes, if you are solving some objective problems on competitive exams like engineering, IIT, or like at JEE, Advanced and all those, then it's better to remember this formula. Like you can't waste like 30 seconds just to derive it. Similarly, can we do for cos 3x? Let's quickly do it. Right? It's nothing but cos of 2x plus x. It is cos a cos b minus sin a sin b, right? Now we have to expand this. We are moving to cos, so this cos I will expand it as like 2 cos square x, 2 cos square x minus 1 times this cos x comes as it is, right? Now this becomes 2 sin x cos x, it becomes 2 sin square x, this sin becomes 2 sin square x cos x, right? Right? Again, if we expand, so same thing, 2 cos square x cos cube x, and then 1 minus cos square x, it will become 4 cos cube x minus 3 cos x. It becomes 4 cos cube x minus 3 cos x, right? So this is cos 3x. Okay, so this is again a good expansion in terms of cos, right? Okay, so this is a good one. Now, quickly we have done this thing, so let's quickly do for now since we have the formula for sin 3x cos 3x, we can easily find what's going to be the formula for tan 3x. Okay, so it's same thing, we are doing sin 3x upon cos 3x. Okay, now what was sin 3x? Or this is one way of doing, or else what we can do is we can simply write it as 10, or we can write it as 10 of 2x plus x, right? So there are two ways of expanding it. Let's take the ratio, or like directly do it for like 10 2x plus x. So we know the formula of tan a plus b is tan a, so it is tan a plus tan b, tan x plus tan y, tan a plus tan b upon 1 minus tan x tan 2x, right? We have the formula for tan 2x, it's 2 tan x upon 1 minus tan square x is equal to 2 tan x upon 1 minus tan square x plus tan x upon 1 minus tan x 2 tan x upon 1 minus tan square x, right? So this becomes easy, right? So what we do is, okay, let's remove this. This part can be removed, this part can be removed, and this multiplied by 1 minus tan square x. So I'm taking LCM essentially, and this one will become 1 minus tan square x, right? And this will be negative. Okay, so this goes, and this goes, right? These two goes, denominators, right? So if what it becomes is 3 tan x, this 2 tan x and tan x becomes 3 tan x. 3 tan x minus tan square x, tan cube x, right? Minus tan cube x, okay? Upon 1 minus tan square x minus 2 tan square x, 1 minus 3 tan square x. That's all, right? So it becomes 3 tan x minus tan cube x upon 1 minus 3 tan square x, right? So that is tan 3x. That's good one. Okay. So we can remember this. Now, so essentially what we have done is we have covered all the ratios, like what is tan 2x, tan 3x, sin 3x, sin 2x, cos 2x, cos 3x, right? Now we can expand like any sort of function that we have, right? Now, so we had cos of x plus y, right? So cos of x plus y is cos x cos y minus sin x sin y, right? That's one. Second was cos of x minus y gives cos x cos y plus sin x sin y, right? Then we have sin of x plus y is sin x cos y plus cos x sin y, and sin of x minus y is nothing but sin x cos y minus cos x sin y, right? So these are the four equations that we have, right? These are the good ones that we already derived, right? Okay, first one was derived and the rest were automatically taken care of. Now what we can do is simply, not a big deal, let's add these two equations, right? So we can add these two equations. So we can do 1 plus 2. When we do this, what we get? We get 2 cos x cos y, cos x cos y, right? These two terms cancel and we get cos of x plus y plus cos of x minus y, right? So that's another expansion, right? Now what we can do is, on the other hand, we can subtract. So when we subtract, which equation can we subtract? So shall we do 1 minus 2? Shall we do 1 minus 2? Okay, so let's do 1 minus 2, okay? We can do 2 minus 1, but let's do 1 minus 2, right? So this cancels, but this becomes minus 2 sin x cos x. Minus 2 sin x sin y, sorry. So this becomes minus 2 times sin y, because this cancels and this becomes minus 2. This minus this, right? And this is nothing but cos of x plus y minus cos of x minus y, right? This is another extension. Okay, now likewise let's do 3 plus 4. When we do 3 plus 4, we get, this get cancelled and we get 2 sin x cos y is equal to, so this adds and this becomes sin x plus y plus sin of x minus y, right? Okay. Now likewise, can we do this minus this, right? Let's do 3 minus 4. Okay. Let's do 3 minus 4. So now what happens is this gets cancelled and this becomes 2 times. This becomes 2 times of cos x sin y. Cos x sin y. This is nothing but equal to sin x plus y minus sin of x minus y, right? So this becomes like this. Okay. So these are also very fairly good equations, right? So what happens is, let's say we have a product and we want to bring it to the sum side, right? We have a product of cos x cos y and we want to bring it to the sum. That's a very good point, right? So this is very much required, sort of factorization of two multiples, right? Sin x sin y into sum of cos. Sin x cos y into sum of sin. Cos x sin y sum of the difference of sin, right? So this is a good factorization. Directly coming from it, but not many times it's like we are not able to see it directly. Okay, let me remove this part, because from here we can derive one more good relation between the functions. And what is that function? What is that relation? Okay, let's see. So I will be showing one only. So how it works is, this is, let's put x plus y is equal to a and x minus y is equal to b, right? So then what is x? Can we solve for x? x is a plus b by 2 and y is a minus b by 2, right? If we solve this, we simply add these two equations. We get 2x is equal to a plus b, that is x is equal to a plus b by 2, and y is similarly a minus b by 2, right? Now let's replace this in this, okay? So what we get is 2 cos a, this is cos of a plus cos of b is equal to nothing but 2 times cos of what was x, a plus b by 2, right? And what was y, cos of a minus b by 2, right? Likewise, we can substitute for all this, right? So it will become cos a minus cos b is 2 minus 2 sin a plus b by 2 sin a minus b by 2 and all those, right? This is actually good factorization. Now look, this is the reverse factorization. From sum we are moving to the product. Here from product we are moving to the sum, and this is really very good. From two angles x and y, we have sin and cos, either x product or x sum. From product we want to move to sum. Yes, we have this coming from original cos a plus b, sin a plus b and all those, right? But if we have to move from sum to product and then to half of those, right? Almost in the ratio of half and all those, right? This is a good factorization. So essentially these are the few good factorization and the few good relations. Now quickly to recap, we started with originally we had the big circle and wherein we tried to prove cos x plus y by taking two congruent triangles and equating the length of the chords. From there we got the equation for cos x plus y, right? From there we derived everything. We said let's replace y with minus y, we got cos x minus y. Then sin x plus y, sin x minus y were directly coming from pi by 2, cos pi by 2 minus x is sin pi by 2, sin x, right? So from there we derived sin x plus y, replacing them y with minus y, we got sin x minus y. The ratio of those two gave 10x plus y, 10x minus y, cot x plus y, cot x minus y, then 2x, 3x and all those, and adding those equations we got the two more factorization, right? So guys, I will recommend, please practice all these things at your own, at your place. Because these are like direct functions, but you might have to remember all these at least. These are the minimum that are required to solve any problem for trigonometry, right? So now, guys, this is the part for the theory part for trigonometry, right? In the next lecture, what we are going to do is we are going to cover some questions which are going to be around these topics, right? This factorization or perhaps some different formula, and then we will move on to the next part, which is going to be the last part of trigonometry, that is solving trigonometric equations, right? So guys, keep watching this space and have a good day. Bye bye.